factors. With respect to the origin O, the position factors given by midpoint AC is find the position factor of M and N. Okay. So let's start by visualizing and drawing some simple diagrams. So the midpoint of AC is M. Just draw like a line, label it A and C, and in the middle it's M. So we know that the A is 0, 5, 2. We know that the C is 4 minus 3 minus 2. So the midpoint should be exactly in the middle between 0 and 4. There will be 2. Exactly in the middle between 5 and minus 3, there will be 1. So just add, divide by 2. So 2 plus minus 2, which is 0, divided by 2, we get 0. Okay, so that's how we find the coordinates of M. 2, 1, 0. Now for N. N lies on BC, so let's draw another diagram. This is B, this is C. We know the coordinates of B, coordinates of C, and such that Bn is to BC. So this is twice of this. So we have this kind of ratio. So first of all, we can always find the factor BC. So how do we get from B to C? What is the process? Well, the process is from 1 we have to add 3. That's how we get 4. Or from 0 we got a minus 3. That's why we get minus 3. Or from 1 we got to do minus 3 to get minus 2. So the process, if you want to go from B to C, this is called the factor BC. Or simply subtract C minus B. So 4 minus 1, we get 3, and so on. So we have the process from B to C. Now, due to this ratio, of course, the process from B to N would be 2/3 of that ratio. So 2/3 of everything here. So instead of plus 3, this is plus 2. Instead of minus 3, this is minus 2, and minus 2. Okay, so just do 1 plus 2, we get 3. 0 minus 2, 1 minus 2, we get the coordinates of N. So that's how we find the coordinates of M and N. Now find a factor equation for the line through M and N. So first of all, we know the position factor or the coordinates of point M and point N. For the line passing through the 2 points, you can use the point M or the point N for the position factor, because this is a point on the line. But for the direction, you gotta use either MN or NM. So to find MN, you can just subtract N minus M. So in this case, we are using MN. So MN means if you want to go from N to N, what is the process? You know, plus 1, minus 3, and so on. Or you can simply subtract 3 minus 2, minus 2, minus 1, and so on. Okay, so this is the factor MN we are using. Right, that's the factor equation. Now find the position factor of the point Q where the line M through M and N intersects the line through A and B. So we already know the factor equation of the line through M and N previously. Now we still need to find the factor equation of the line through A and B. So same concept, we can use point A or point B. Here we are using point B, and we can use the factor AB or BA. So here we are using the factor AB. So subtract, 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 we get the factor AB. So to find the intersection point, we equate both equations. So if there is a point which is on both lines, then the position factor must satisfy both equations. So this is, say, Q is the position factor. It says point Q. So it's got to be on the red and the blue line. So to find the point, we just analyze each component. So for the x component, we have the first equation 2 plus 1 times lambda, 2 plus lambda, equals 1 plus mu times 1, so 1 plus mu. So that's from the x component. From the y component, 1 minus 3 lambda equals 0 minus 5 mu. So that's from the y component. Now we can substitute or eliminate to find the lambda and the mu. So here we can multiply throughout by 3. So everything times 3, we get this, and then we can just add to cancel out the lambda, to eliminate lambda, and then we get the value of mu. If we solve, we get the value of mu. And after we find the value of mu, we can plug into one of the equations. So just use this equation, replace the mu with minus 2, we can find the lambda. So after we find the lambda and the mu, actually we have to use the third component to check and make sure we have the intersection here. So 0 minus lambda equals 1 minus mu. We plug in the values of lambda and mu we have found before, so minus 2 and minus 3, and make sure it checks. This is 3, this is also 3, so this is right. We have the right values of mu and lambda. And to find the position factor, we can use either equation. We can use the red or the blue using the lambda or the mu, but we will get exactly the same result in the end, same position factor, because this point is on both lines. Alright, I'll see you again next time.